Hello student, this is Sanjay sir from Mathswell YouTube channel. Today we are discussing about the one of the important concept from the maths that is from this chapter set, and from it we are going to discuss today with a concept of operations on the sets, and the examples depends on it. So let's see one by one. The first one is a union of two set. Okay, so what is the union of two set? Union of two set, it is a set of elements present. Suppose the two sets are given, say A and B. When you are given two sets A and B, then the union of two sets A and B will be defined as the set of elements which are present either in A or in B or in both the sets A and B. But the common element should be taken only once. Even the some elements are present in both the set A and B. In that case, we need to take those terms, those repeated elements only once. So that gives us the union of two set. Okay. So the symbolic notation for it, union of two set will be this: A union B, and we read it in the same way, that is A union B, or union of the sets A and B. So let's see example for this. Let us consider the two set A and set B. Set A contains the numbers 1, 2, 3, 4 and 5, the 5 natural numbers. B contains the numbers 3, 4, 5, 6 and 7, again 5 natural numbers from 3 to 7. What will be its union? The union of these two sets will be, as per definition, it is a set of elements which are present either in A or in B or in both, right? So firstly down all the elements in the set A, there are 1, 2, 3, 4, 5, and then the remaining elements from the B, which are except the elements from A. So here if you see in the set B, 3, 4, 5, 6, there are 3, 4 and 5, they are already taken from the set A. What are the remaining elements? We left with 6 and 7. So those should be added with the elements in set A. So together it gives us union of the sets A and B. That is A union B. It will contain the numbers 1, 2, 3, 4, 5 and then 6, 7. Okay. So in this way we can find union of two set. This union of two set can also be written in the set builder form, in symbolic form, as this. It is a set of X. As we know, we need to write only the rule under which the elements are there in the set. So here the rule is the set of all such numbers X such that X belongs to A or belongs to B or belongs to A and B, either in A or in B. So that is the condition for the union of two sets. Okay. So this is the way to write the set in set builder form, and that is union of two set. Hope everyone got this concept. Now let's go for the second operation. The operation number 2 is the intersection of two sets. Again consider the two sets A and B. So for those two sets, then we can define the intersection of two sets A and B as the set. It is a set which consists of the elements which are present in A as well as in B. That is what it says. It says that it is a set of common elements in the sets A and B, right? Only the common elements. See the difference between these two, union as well as intersection. Union contains all elements present in A as well as in B. That is, they are either present only in A, only in B or in both. All elements should be taken in union of two set. Whereas in case of intersection of two set, only the common elements should be collected together. So that gives us intersection of the two sets given. So keep this difference between the union and intersection of two set. Union will have all the elements present either in the first set or in the second set or in the both sets, whereas the intersection will be the set of only those numbers, those elements which are common in the given two set. Okay, that is the difference. So the notation for A intersection B will be this one. What is the notation? Symbolic notation is this. Okay, so this is the symbolic notation for A intersection B. Okay, so we'll read it in the same way, that is A intersection B. Okay, So A intersection B in symbolic form, again we can write in set builder form in this way. That is, it is a set of all such x's such that x belongs to A and x belongs to B. Here the connective used is and means it is compulsory both A and B. Hence, this is the way to write the set in set builder form, that is intersection of two set in set builder form. Okay, so let's see the example for this too. This intersection of the set. So consider two sets A and B. A contains the numbers 1 to 5, the natural numbers. B contains the numbers 3 to 7, again natural numbers. And if we take the intersection of these two, we need to write only the common elements among these two sets. So if you observe these two sets, what are common? 1 is not in B, 2 is not in B, 3 is there, 4 is there, 5 is also there in B, but 6 and 7 they are in B but they are not in A, means only the numbers 3, 4, 5 they are present in both the sets A and B. So I need to write only these three numbers in the intersection set. Hence I can write A intersection B as 3, 4, 5, the set containing the numbers 3, 4 and 5 only. Only the common numbers among these two sets, only the common elements among the given two set will give us intersection of two set. Hope everyone got these two concepts now, union as well as intersection of two sets. Now using this intersection of two set, I need to define one term known as a disjoint set. What is disjoint of two set, or disjoint two sets are said to be disjoint? What is the condition for the disjoint? Is like this. If you see the definition, if A and B are two set such that A intersection B is 5, so this is the very important condition to be the disjoint set. That is A intersection B, that is intersection of the two set. If it is a null set, 5 means what? 5 is nothing but a null set. Null set means empty set, there is no element between them. Okay, so nothing is common among these two sets. So such sets are known as a disjoint set. Joint means they should have some common. Disjoint means nothing is common among them. Okay, so in that case I can say the sets are disjoint set. Everyone got this? Okay, so I will repeat once again. If A and B are two sets such that A intersection B is 5, that is null set, or we can say it is a set of, since the two sets have no common element, in that case I can say the two sets are disjoint set. Okay, so these are the disjoint sets. So let's consider the example. So let's consider the sets given. A is the set containing the numbers 1, 2, 4, the natural numbers. B contains the numbers 5, 6, 7, 8, again natural numbers. If we take their intersection, means we need to check the common element among these two. So what are the common elements? If you see, A contains 1, 2, 3, 4, B contains 5, 6, 7, 8. Is there anything common among them? Nothing is common. A has 1, 2, 3, 4, B has 5, 6, 7, 8. Nothing is common. So what can I have? I can have the intersection of two set is a null set, empty set. Hence I can conclude that the given two sets are disjoint set. Right? So that is the case here. This is the example for this disjoint set. Now let's go for the third one. The third operation I can say. Basically we have two operations, union and intersection. I can say this one is also one of the operation known as a difference of two sets. Let's consider the third operation, difference of two set. So let's define it. Difference of the sets A and B in this order. So order is very much important for this. Difference of the sets A and B in this order means it is A minus B. Is the set of elements which belongs to A but not belongs to B. Right? A minus B is the set of elements which belongs to A but not in B. Okay? So this is the difference of two sets. It will be clarified in the example. Okay? So the symbolic notation for A minus B is as usual. We just put the minus sign between these two sets A and B. So A minus B is the required set. So how to calculate A minus B? By definition, let's see. Let's consider the example. Consider the two sets A and B. Set A contains the numbers, natural numbers 1 to 6. B contains 3 to 7. Take the difference of A and B. So A and B means it is A minus B. B and A means B minus A. So keep the order in mind. Whenever you are asked A and B, we should take only A minus B. If you are if you are given to find difference of B and A, then in that case you need to take only B minus A. It means B minus A only. Okay. So A minus B means the set of elements present in A but not in B. A contains the numbers 1, 2, 3, 4, 5, 6. B contains the number 3, 4, 5, 6, 7. So which are the elements from A are also present in B? The numbers starting from 3. So 3, 4, 5, 6. These 4 numbers, they are also present in set B. So we need to delete these 4 numbers to get A minus B. So I left only numbers 1 and 2. So that gives us the difference of A and B. So I have A minus B as 1, 2, the set containing numbers 1, 2. Now let's try to find B minus A and check whether they both equal. Okay, so what is B minus A? So again, while taking B minus A, the again order is important. We need to take difference of B and A. So B minus A means the set of element which are present in B but not in A. Okay, so again see the elements from B which are also present in A, and those should be deleted from it. So from the set 3, 4, 5, 6, 7, the set B, again the numbers 3, 4, 5, 6, they are also present in A. We should skip these numbers, and what is left? We left with only 7, and that 7 should be nothing but the difference of B and A, that we have B minus A. Is it clear? So from these two statements, from these two calculations, A minus B and B minus A, we should conclude that A minus B and B minus A are not equal. Okay, so A minus B is not equal to B minus A. This we can conclude from this example, that the difference in order, they are not equal. That is either A minus B or B minus A. So it is not the condition that they should be equal always. In some example they may equal, but it is mostly it is not. Okay. Now let's find A intersection B. What is A intersection B? A intersection B, again as we seen earlier also, it is a set of common element. So let's see the common element among these two sets. Which are the common elements? Again, as we have seen, 3, 4, 5, 6 are common elements. So we can write the intersection of two sets as the set containing the numbers 3, 4, 5, 6. Okay, so now we have the three sets with the operations difference and the intersection. So difference is A minus B is 1, 2, B minus A is 7, and A intersection B is 3, 4, 5, 6. If we observe, what we can conclude from it? So is there anything common among these three sets? Nothing is common between these three sets. So whenever there is nothing common between any two set or more than two set, what we can call? We can call them as disjoint set. Here we have seen the definition. Whenever the intersection of the two set or more than two set, it is not equal, means they are not 5, nothing is common among them. In that case we can call them as disjoint set. And here, since the three set A minus B, A intersection B and B minus A, the intersection of them is 5, a null set, we can call them as mutually disjoint sets. Okay, so in this way we can conclude that the A minus B or B minus A or A intersection B, they are all disjoint sets. Hope this part everyone got it clear. So now let's go for the next one. What is the next part? The next part is the properties of union as well as intersection and their Venn diagrams. How to represent union and intersection of the two set using Venn diagram. So let's see them one by one. First we will discuss about the properties. They are very simple properties and similar properties among these two. The first one is the commutative law. Commutative law for union is A union B equal to B union A. The same thing is here for intersection also. A intersection B is equal to B intersection A. Even we change the order, they will remain same. So in that case we can say they are commutative. Union as well as intersection both are commutative. The second case is associativity. So again if we see, for union it is A union B, union C is same as A union B union C. The same case for the intersection also. A intersection B intersection C will be same as A intersection B intersection C. So such type of property is called associative law or associative property. So here I can say union as well as intersection both are associative. Okay, union is associative means this condition is satisfied. Intersection is associative means this condition is satisfied. Okay, for the next one, law of identity. Law of this empty set we can also say. So A union phi, that is union of any set with or null set will be the set A itself. So if you have taken the set A, so union of A with phi will remain A only. Whereas in case of intersection, intersection of A with phi will be phi only. Okay, so that is the difference between these two. Okay, now union intersection of union with A will be A. That is the case. Okay, after that we have the fifth one, A union A is A, that is union of A with itself, that is union of a set with itself will be the set itself only. Whereas for intersection also the same condition is satisfied, A intersection A will be A only. So such type of law is known as a idempotent law. Okay, so union as well as intersection both satisfy this law. Then finally we have, for the union we have U, that is the union of universal set with A will be U. Whereas here if you see, intersection of universal set with A will be A only. Whereas for union it is universal set U only. Okay, and then we have the one more new property for the intersection of two sets. It is known as a distributive law. It is distributive of intersection over union, and it will be defined as A intersection B union C is equal to A intersection B union A intersection C, right? So that is called the distributive law or distributive property. So these are some properties for union and intersection. So this will be helpful while solving the examples. Okay, now let's see the representation of the union, intersection and difference of the sets using Venn diagram. Okay, so if you just observe the diagrams, you can come to know how to represent this union, intersection and the difference of two set. Union will be the set, as by definition it is a set of all elements present either in A or in B or in both. So we have to just highlight the whole part of the sets A as well as B. So this shaded region will give us A union B. Whereas for intersection only the common part should be shaded. So this common part should represent A intersection B. And for the difference of two set, as we have seen, difference of two set is nothing but the set of elements which are present in A but not in B, right? So that is purely the part of A only. Okay, so no common part among A and B should be there. So only A minus B will be the set of elements which are present in A but not in B. That this Venn diagram represents A minus B. Similarly, if you want to show B minus A, this part will be there, only the part of B except this common region among A and B, that should also be excluded. Okay, so that gives us difference of two sets using Venn diagram for all concepts. So once again, bye everyone, take care and keep learning. Thank you very much.